Hello and welcome. Thanks for joining me. This is a tech talk on getting started with serverless for developers. My name is Benjamin Smith and I'm a senior developer advocate for AWS Serverless. I've been a web developer for about 15 years and specialized in business and workflow automation. Really, the most important thing on this particular slide is my contact information. So if there's any questions that you have during the course of this tech talk, then please do reach out to me either on Twitter. My Twitter name is Benjamin_L_S, or via email at benjasl@amazon.com. Now, everything I'm going to talk about today is part of a multi-part blog post series, which is all about getting started with serverless for developers. And as I cover the relevant topic, you'll see a link at the top of the slide here that will take you to that relevant blog post. So look out for that as a means for you to dive deeper and read more about some of the topics discussed here today. Now, today's focus is you, really. It's about the developer. So this is a tech talk for developers who are already building applications but are completely new to serverless technologies. And so this is coming very much from a hands-on point of view. We're going to cover why developers need serverless technologies and what serverless technologies can actually do for you as a developer. And then we'll look at how you implement serverless technologies to build an application. Now, if you've looked into serverless before, you've probably seen a definition similar to this, where it's discussed as a means of building applications that scale automatically without maintaining, running, or patching infrastructure. And that's very true and a very sort of generalized definition of what serverless is. But what serverless means to developers is sometimes slightly different. So before starting this new Getting Started blog series, I actually reached out to the community on Twitter to ask what serverless means to them. And I think some of the responses are really interesting, and I just wanted to share some of them with you quickly before we jump in. So one response here is to just put my code to work, don't care where the server is. Another one here, code is a liability. How little code can I write by taking advantage of AWS managed services stitched together with direct integrations? Focus mainly on the code, secure and easily scalable, combined with infrastructure as code makes it a joy to develop with. This person says, not having to do a ton of work and maintenance, easier to build things. This one, lowest barrier to entry to running a piece of code in the cloud. Less code, less stuff to go wrong. Portability of code, empowered development, more scope for fast proof of concept work. Serverless means I'm not actively managing resources. There's an API for a managed service, I use it, and it just works. Serverless is not worrying about anything other than the code and the billing. The power to know that I can do anything in AWS's platform. Trust external services to do their job instead of building it on my own. It means I have to deal with servers less. Decoupling global enterprise scale apps. Largely, each one of these replies can be grouped into one of three main categories. Okay, and I've actually done that for you here in the next slide. They can either be grouped as I only want to write business logic, and this is about allowing you to focus on what differentiates your application from another application. It's not necessarily the infrastructure that stands up your application, it's the business logic, the code. The actual functional part of your application is what differentiates you from your competitors and what helps you delight your customers. I don't want to pay when my workload is idle. So this is all about the billing for serverless technologies. Essentially, if you're not consuming that resource, if you're not running that resource, you shouldn't be getting billed for it. And that's a fundamental part of what serverless is. And I want my application to scale on its own is the other category that we see. And this is all about allowing you to build serverless applications where all you have to worry about is implementing the business logic, and the application itself will handle the traffic and the scalability for you automatically. And we'll look at how it does that in this next slide here. As applications mature and grow, they will often need to handle increasing levels of traffic. And this is where the scalability challenges can sometimes arise. So developers might need to invest in additional architecture or personnel to try and meet those challenges. Serverless technologies help to solve this by scaling automatically to meet the increase in demand. And they do that by applying a horizontal approach to scalability rather than a vertical approach. So a real life example of a horizontal and vertical scalability can be seen in this little illustration here. Imagine one person needs to travel from home to a birthday party, and they use a bicycle as a sufficient mode of transport to carry one person. If then two people need to travel together, a bicycle is probably going to be too small, and instead they might need to hire a taxi. If four people need to go together, then a bus is required, and so on and so forth. So that's an example of vertical scaling. Each increase in load requires the purchase of a larger transport mode to bear that load. And if you apply that same method of scaling to an application, it means that each time a server starts to reach its capacity limits, an additional server will be required to increase that load capacity. If you imagine the same four people each travel on their own bicycle, that's the load being spread evenly. So this is a lot more flexible because as traffic grows, you can just add an additional capacity unit. And that's known as horizontal scaling, and it's what allows serverless technologies to scale flexibly. With traditional applications, you often need to over-provision. So what do I mean by that? It's about having additional resource capacity to accommodate a spike in demand. That additional capacity will remain largely unused, and you can see from this simple illustration here, as you have an event or a request come in, you need to scale up to meet that demand. You're constantly having to overscale or over-provision so that you have reserve capacity to meet any spike in workload. And what that means is that you're paying for this unused capacity all the time. The horizontal scaling model, though, means that resource consumption scales up and down with your application's demand, and that can make serverless a more cost-effective model for applications with more variable levels of traffic. A simplified scenario which many developers will face is a need to do something with some data to produce a valuable output. And that something can be referred to as business logic, and it's at the core of every application. With a traditional non-serverless application model, the developer's got to prepare a whole bunch of things before they can start creating that business logic. Many of these things are generic and repetitive tasks, such as provisioning databases or servers, or setting up backup and resource systems, securing the server, patching an update, raising a ticket perhaps for an ops person to do that. But using serverless technologies abstracts away all of those tasks, right? So really the only thing that you have to think about before starting building your application is what language or runtime you want to build with, and then you can just start right away. There's a great many number of applicable use cases for serverless technologies. It's almost limitless, but some of the common use cases that we see customers implementing are listed here. Really, any application that needs to handle variable or unpredictable levels of traffic is probably a really good fit for serverless technologies. I'm going to show you an example of how to use serverless technologies to do this first item here, which is connecting two applications together. In this case, I'm going to build an application which will connect GitHub to Slack, and the arrow in the middle is our serverless application or serverless technologies that we're going to use to connect these two applications. And what this application is going to do is whenever a repository in GitHub is starred, it will send a message to a Slack channel giving an update about that particular repository, how many stars it has, and who made that new star. I'll just demonstrate that application in motion before we jump into the build. On the left here is my Slack channel, and on the right is my GitHub repository for the getting started code samples. And you'll see if I just click on this star icon over here, instantly that sends an event to my Slack channel to say that there's been a new star on my repository. Let's talk a bit more about business logic. I mentioned before that when you need to do something to some data to produce a valuable output, that something is what you might call business logic. Usually that's your custom written code. Now we know that applications often consist of different components or layers. With traditional applications, each of these layers will often be defined by your business logic, or at least tightly coupled to it in the same code base. This is sometimes referred to as a monolith application. And one of the big differences of building applications using serverless technologies is that your business logic is decoupled from these other application components. This is because you can configure managed services to handle those layers, and the remaining components that can't be run by managed services is what you create with your custom code. The serverless application deployed in blog post part 1 uses GitHub's webhook integration capability to notify users via Slack when a repository has been starred. It receives an event from GitHub's inbound webhook, extracts the relevant information from the webhook, transforms it into a format that Slack accepts, and posts the results to a Slack channel. Now let's zoom into this mystery serverless arrow and take a look at what managed services are being used and what business logic is being implemented. Here's a more accurate representation of our serverless application. And the business logic here is the part that transforms the data into a valid Slack payload and then makes a post request to Slack. But where do we put that business logic? It's all contained inside a single AWS Lambda function. Now, a Lambda function is a packaged piece of code that performs a specific task. Code is written by the developer and uploaded to the function. And the Lambda function is then run by the Lambda service in your AWS account in response to an event. And it's able to run for almost any scale of traffic. Your Lambda function code can be written in any number of different runtimes or languages, and many of these are supported natively. So some are written here: Node.js, Python, Java, Go, Ruby, C#. And with the custom runtime API, you're able to bring any Linux compatible runtime to your Lambda function code. Now, your Lambda function doesn't just sit in a vacuum. It typically forms part of a serverless application and is comprised of 2 or 3 different components. There's the event source, and this is the event that invokes your Lambda function and tells it to start running the custom code that you've uploaded to it. And this event can be a number of different things, from a change in database state, a direct request from an HTTP endpoint, or a change in resource state from any number of integrated AWS services. Then there's the function itself, and that's the custom code that you've uploaded to your Lambda function, the business logic, and then there's the service that your Lambda function will integrate with or output to. And this can be any number of things depending on what your application is required to do. So in the example of our serverless application here, the service or the output is posting a request to a Slack channel. And the anatomy of a Lambda function is something quite interesting in itself. Like many applications, it can actually be deconstructed into 3 fundamental components: input, process, and output. An event instructs the Lambda service to start running the function. In the example application, that event is the inbound GitHub webhook. The input is provided to the function as an event payload, and the process is the code or the business logic that you upload to the Lambda function. The output is then the JSON response returned by the function. And every Lambda function must have what's called a function handler, and this is the entry point or the starting method for your Lambda function code to start running. You can also think of the Lambda service itself as a kind of dartboard with various rings. So going from the outermost ring inwards, first there's the Lambda compute substrate. This is the underlying compute layer for all of Lambda. Next, there's the Lambda service itself, which manages the scheduling and the organization of workloads across hundreds of thousands of customers. And both of those layers are completely invisible to the customer. They're managed entirely by AWS. Then, the next layer in is the execution environment. Now, this is customer specific and AWS account specific. It's the secure space where your code itself is run. Inside each execution environment, there's the language runtime. And then finally, inside of that, there's your function. That's the code you provide, zipped up or packaged as an image with any dependencies required. In terms of storage that's built into your function with Lambda, you have the memory that your function can be configured for, and this can go up to 10 gigabytes, and that's a different 10 gigabytes of artifact storage that you have. In terms of temp space, you have up to 512 megabytes of temporary file space, and you can deploy your Lambda function either as a zip file or as a container image. Now, if you use a zip file, you have up to 250 megabytes that you can use. If you use a container image, you can deploy Lambda functions of up to 10 gigabytes in size, which is great for things like machine learning models, scientific libraries that you want to include, anything that you might need inside of your function to operate. So I have a Lambda function that contains the business logic to transform my payload into a format that Slack will accept, and it makes an HTTP post request to a Slack channel. Next, I need to create a front door to access that business logic. I do that by building an API. Now, using APIs to access business logic is not a new concept, but using a managed service to create my API helps me to create it without having to write any additional code. I'll explain how. Coming back to my application architecture diagram, we'll reveal the managed service that I use to access the custom code in my Lambda function. And that service is called Amazon API Gateway. API Gateway is a fully managed service that allows developers to create serverless APIs to run at almost any scale. And these APIs can be configured to access your application business logic. In this example, API Gateways is used to create a URL endpoint. When the URL receives the HTTP post request from GitHub, it invokes the Lambda function. And I mentioned before how traditional application architectures hold all the business and routing logic together as a single unit or single code base. In contrast to this, serverless applications will use managed services to separate the business logic from other application components. And one of those components that can be decoupled is the routing logic. Here's how it works. If you take an example of a manager-worker model, typically the manager's role is to take incoming requests and decide which worker should do the work, and then they pass that request to the correct worker. The worker receives the request from the manager and carries out the task, but is not necessarily responsible for deciding about the bigger picture. The worker just returns the completed task back to the manager. Applying this same model in a traditional non-serverless application, the worker and the manager are both implemented within the business logic. That's the code. In a serverless application though, the manager is implemented using API Gateway, routing requests to the business logic. The business logic then runs within a Lambda function. In a traditional application, I need to update my code each time I need to handle a new type of request. Whereas using API Gateway, I can just add a new API route and configure it to invoke a new Lambda function for each additional inbound request type. There's no routing code to maintain, unlike with my traditional application model. You've heard a lot about how serverless applications lean heavily on managed services to decouple business logic from other components and reduce the amount of custom code that you need to write. As your application then starts to grow using more and more managed services, you'll find that using an infrastructure as code framework will help you to track the various types of services and resources that are being created and configured. The AWS Serverless Application Model, otherwise known as SAM, is an open source framework for building, deploying and managing serverless applications. And it's split into two parts. You have SAM Templates and SAM CLI. Now, SAM Templates let you use shorthand syntax to describe AWS resources to build serverless applications. And these templates can be built in YAML or JSON. The SAM CLI then is a command line interface that helps you locally test and deploy your applications to your AWS account, all from your local machine. Here's an example of a SAM template that's written in YAML. These 20 lines of code describe an application that uses a Lambda function, an API Gateway endpoint, and a serverless database table for Amazon DynamoDB, along with all the required security permissions for the application to run. Here's how that application looks if you draw it out as a service architecture diagram. I'm going to show you now how to deploy the serverless application that I've been referring to in this talk. First, I'll configure Slack to provide a channel post URL for the serverless application to post out to. Then I'll clone and deploy the serverless application from my local IDE to my AWS account. This will generate an API Gateway URL that I'll configure GitHub to post to each time a repository is started. Finally, I'll show how to edit business logic in my application and how I extend it to process other GitHub events. And I'll show you how to do all of this without leaving the place that you're most comfortable building in, and that's your local IDE. So this is my Slack channel here. The first thing I'm going to do is configure my Slack channel to install a new webhook integration. And I'll do that by right-clicking on the channel that I want to install the integration into and going to the More Details page and then the Integrations tab. Then I'm going to search for incoming webhooks because that's the integration type I want to install. And I'll click on Install here, and that brings up the configuration in my web browser, which I'll just show you here. So I'll just click on Add to Slack, and now that's setting that up in the background for me. What this will do is it will provide me with a post to channel URL, and I can use that channel to send a payload directly to this Slack channel. And I'm going to use that in my Lambda function to make a post request to the Slack channel. And that Lambda function will then run whenever an action happens on my repository. And I'll show you how we configure that to run in just a moment. So the bit to take from this is my post to Slack URL. I'll just save the settings, and I've copied that to my clipboard now. So the next thing I'm going to do is to jump over to GitHub, where I have an example version of this application. I'm going to git clone that application to my local machine, and then I'm going to deploy it to my AWS account. And when I deploy it, it will ask me for this Slack post channel URL, which I will paste into the deployment wizard. And I'll show you exactly how that works in just a moment. So here's the GitHub repository. It's broken up into 5 parts. Each part reflects a blog post on the compute blog, AWS Serverless compute blog. This is the clone URL that I'm going to use to clone this application to my local repository. So this is my local IDE, and I'm going to just run git clone and then paste that repository URL directly into here. Let me just grab that again. Here we go. Paste that in. Now this will download the application repository and all the files that I need, my Lambda function files, my SAM template definitions, and the various folders. I'm going to change directory into the root of that application. And then I'm going to change directory again into the part 1 of the application, which obviously accompanies the first blog post in the series. And I'll just show you what's inside this part 1 folder. We have the template.yaml, which is my SAM template file. And then we have the src, or the source folder, which holds my Lambda function code. So I'll run a SAM build on this and a SAM deploy. So what this does is it's packaging up any dependencies which my Lambda function is using. So for example, my Lambda function is using Axios, which is a node module for posting requests. And when I run SAM deploy to deploy my application into my AWS account, it's asking me for some parameters or some arguments. The first thing it's asking me for is to name my application. So I'll call it Getting Started App. The next thing it asks me for is the region that I want to deploy my application into. So I'll tell it to deploy to US East 2. Now you see this parameter that says Slack URL, and this is where I paste in the Slack post channel URL that was generated when I installed my Slack integration. There's a few other parameters here that it's asking for, which I'll just fill out, and then the deployment process runs. And this is going to deploy my single Lambda function, which will post to my Slack URL, and it's going to deploy an API gateway URL, which is the kind of access or the front door to my Lambda function. So whenever that API gateway URL receives a post request, it will run the Lambda function. The Lambda function will then send another post request to my Slack channel. So once this is deployed, the next thing that I have to do is to get the Amazon API gateway URL and configure GitHub to post to that URL anytime a repository is starred. And I'll show you how to do that in just a moment. So here's the output. In this output you can see it says GitHub endpoint, and this is the API gateway URL which I need to configure GitHub to post to whenever my repository is starred. So I'll show you how I'll set that up in GitHub just now. I'm going to jump back into GitHub here, and I'm going to use the same repository to set up my webhook. So I go to settings and then webhooks, and then I'm going to add a new webhook, and this is going to be where I paste the payload from my API gateway URL, and I'm going to select the content type to be JSON. Now I get to pick which event I want to trigger this webhook. So I'm going to pick the watches event, which means whenever my repository is starred, this event will be triggered. So that should all be ready. I'll save my webhook, and that takes me back to my repository page. I'll go back to the home page of my repository, and I'm going to unstar and then hit star again, and that should invoke my Lambda function via API gateway from this webhook integration. And then you can see it sent that directly to my Slack channel, and that's all worked nicely. Okay, good. Now let's say I want to edit this. I want to add some more information to the payload that's sent to Slack. Now, in order to do that, I have to update the business logic, which means changing something on my Lambda function code. So this is actually blog post part 2 in the Getting Started series. So I'm going to change directory into part 2 here. And I'll just show you part 2 in the directory structure. So here's my source, here's my Lambda function code, this is my business logic. And here you get the first look at what my code is actually doing. So there's a constant variable which holds the avatar URL of the person that made the star on my repository. And I want to send that to my Lambda function code so I can see their profile icon when they make their star. And I know that this avatar URL is available because I can inspect the payload that is sent from the GitHub integration. I can do that by going over to GitHub here, going to settings and looking at a previous webhook invocation. So if I drill down into this invocation here and I go to recent deliveries, there's been a few recent deliveries here, and if I go to the sender object, you can see that there's a field in here called avatar URL. So that's what I want to send to my Slack channel. That holds the profile picture of the person who starred my repository. So I'm going to add that into my message here that gets sent to Slack. I'll save that. I'll go back to my SAM template, and that's exactly the same. There's no change in my SAM template for the part 2 of the application. So I'm ready to now rebuild and redeploy this to my AWS account. So I run my SAM build again. That will repackage this this app.js file where my business logic is. Essentially, that's my Lambda function custom code. And then once the SAM build has run, I want it to run SAM deploy. This time I'm not going to do a guided deployment because I've already gone through those steps. I'm going to deploy directly to my AWS account, and I'm going to use this config file that I created in the previous deployment, the same config file to deploy that. So this will repackage my Lambda function code as a zip file and deploy it to my AWS account. Once that's deployed, when invoked, it will also send the profile image of the person who starred my repository along with the rest of the payload. So we should see a richer message coming into Slack now with that profile image as part of the Slack message. And nicely on cue there, our deployment has finished. So let's jump back into GitHub and once again unstart and restart the repository, and we'll have a look at that richer payload in our Slack channel. That should be pretty much instantaneous now. I'll do that a couple times and we'll jump back into Slack, and there you go. You can see that's been sent through a few times with my beautiful profile image there of me in the mountains. There you go. Right. So that's me having updated my business logic or my function code directly from within my local integrated development environment, my IDE. And then I redeployed that to my AWS account. Okay, let's say I want to extend my business logic. I want to add some new functionality. This is actually part of blog post part 3. So I'm going to change directory into part 3. Now, I'm going to extend my serverless application to handle a different type of GitHub event. And this will be for an event when a user pushes a new commit to the GitHub repository. Now, in order to do this, I'm going to have to create a new Lambda function. And this will have a slightly different function code and slightly different transform to the GitHub star event. I also have changed the application folder structure. If you look closely here, you'll see that I now have 2 source folders. And one is for the previous star event, and there's a new one now for this push event. Within each folder is an app.js file with the relevant Lambda function code. Then, in terms of the AWS SAM template, the easiest and the quickest way to extend the app is to simply duplicate the YAML definition that describes my existing Lambda function and its API gateway endpoint. I give it a new name and configure it to the new src push folder so that it's invoking the correct Lambda function. So this function will be called push webhook handler. It's going to be located in the src_push directory, and it's going to create a new API gateway URL whose endpoint is at /push. That's all I need to extend this application. Let's have a quick look at how the business logic differs. So I'll drill down into the source push directory and open up my app.js. Okay, so it's going to say a new push has been made, and it tells me which repo the push has been made to, and it'll also tell me who the push was made by. And that's pretty much the only change. Everything else is fairly similar. It's going to have the same kind of payload that Slack will accept. It's just taking a different kind of data from my inbound webhook from GitHub, and it's going to transform that and add that to my message to Slack. If I want to edit this particular message at any point, I can just jump back into this function code for my push event and edit that directly without it affecting the star event that I've made previously. And that's how I can keep my business logic nicely decoupled from each other. Okay, so now I quickly build and redeploy my application with a new Lambda function and a new API gateway endpoint URL. I'll then have to go back into GitHub and tell it about this new API gateway endpoint URL. And I'll have to tell it to send to that endpoint when there's a new push event. You'll notice now that deployment is complete, and I have two API gateway endpoint URLs. One for my star event, which we've already been using, and one for the new push event. And you can see the one for the new push event has a extra root at the end, which is /push. So I'm going to paste this into GitHub now. I go back to the webhook integration setting and I add a new webhook. I'll paste that payload URL into here, and then I select application, JSON, and I'm going to make sure that the push event is selected, which it already is, and I'll just save this webhook integration. And that's all I need to do to configure this to send to Slack now via my serverless application. I'll go to the home page and we'll just test that out by making a very sort of trivial push event. I'll just commit something to the README file, and I'll just let that be the default update README, and I'll commit that change, and we should see that instantly send an event to my Slack channel. Here we go, a new push event has been made, and that's worked very nicely. So that's me extending my application to include a different event without having to edit the previous business logic or edit the previous routing logic. I have my routing logic nicely decoupled from my business logic, and I'm able to do that just by duplicating the SAM template code. So what about local developer workflow? How do you check logs, test, and iterate on your business logic locally while you build? With traditional non-serverless applications, developers commonly create a development environment on their local machine. And that local development environment keeps parity with the staging and the production environments. That's what allows developers to test their application locally end-to-end before committing code to the main branch. Serverless applications, though, pose a different challenge, since they use managed services that run in the AWS cloud. How then do you develop locally? You need to maintain a fast inner loop as you build out your business logic, without having to deploy to AWS each time you make a code change. Also, how can you test against these managed services? Now, sometimes we see developers trying to emulate cloud services on their local machines, because they're so used to replicating everything locally as they build. My recommendation is not to do this, and you don't have to either. Here's how to maintain a fast inner loop as you build serverless applications. So first of all, build your business logic locally. That's your custom code for your Lambda function. Then create a local test harness file, and this file needs to reference any relevant environment variables that your Lambda function code uses. It might also need to import an example event object. Then you can run your Lambda function code locally via the test harness file. This then becomes your inner loop, allowing you to test function code locally and monitor log outputs without making deployments to your AWS account. If your Lambda function code interacts with other AWS resources, maybe it's using the AWS SDK for example, then you can deploy those resources to a Sandbox developer account and include the SDK as a dev dependency in the function's package JSON or the equivalent for other runtimes. This way you're able to continue to iterate on your inner loop locally. Once your business logic is working as expected when run via the test harness file, you can deploy your Lambda function to a Sandbox developer account as well, and here you can test for other things like security permissions and other environment configurations. And you can still invoke the function from your local IDE and monitor the output logs from your local IDE too, as they're written into your terminal window. Then, once your Lambda function is working as expected in your Sandbox developer account, it's time to commit it to your various code repository branches, where your automated CI/CD pipeline can run and deploy into the relevant environment. Next, I'll demonstrate this developer workflow for you. Okay, so back to my IDE. I'm going to change directory into part 4 because this has got all the relevant files for you. First of all, let me just open this up a little bit and we'll zoom in on the start event. So here you can see I have my app.js, that's my Lambda function code or business logic. I have my package.json, which contains all the dependencies that my Lambda function will use. And I have this new file called testharness.js, which I'll show you in just a moment. Notice also that I have an environment file called env.json, and this will hold the local environment variables that I will need in my Lambda function. I'm going to use the AWS SDK for JavaScript. This is so that I can save the event payload as a txt file to an S3 bucket. Amazon S3 is an object storage service which is almost infinite in scale, and I can use it to store and retrieve pretty much any amount of data from anywhere. So I'm instantiating S3. Further down in the code here is where I use an environment variable to grab the S3 bucket location, and here I'm using the SDK to put an object to my S3 bucket. Let me show you the test harness file. So first of all, the test harness file requires a mock event, and that's held in testevent.json. It also requires an environment file, which is held in env.json. So I need to add some values to those two files. I already have my test event here, and this is explained how to generate this in the blog post. Essentially, I've just mocked up a test event using the SAM CLI and then grabbed a real payload from GitHub looking at the previous webhook deliveries. Now I'm going to add some values to my environment file. It needs to know the Slack endpoint URL and the S3 bucket that I'm going to create once I deploy my SAM template. Because my Lambda function is now interacting with a managed service on the AWS cloud, that's S3, I need to deploy that S3 bucket to a Sandbox developer account. So I'm going to use the SAM CLI to build and deploy my serverless application. Then I can run my function code locally and test it against those managed services. While that's deploying, let me quickly show you the SAM template. Here's the configuration that gives my Lambda function permission to write to an S3 bucket. The description of that S3 bucket, and here I should expect to see the S3 bucket name in the output once the template has deployed. Now that it's deployed, I'm going to copy and paste the S3 bucket name, and then I'll put that into the environment variable file. It's just this value here. Copy that to my clipboard and move that into the environment variable file. The next thing I need to put in here is the Slack endpoint, so I'm going to paste that in from my clipboard as well. Now I should be ready to test this Lambda function code locally. So first I need to change directory into the src starred directory. In this directory I also need to run npm install so that my Lambda function has available to it the required node modules. And it's going to grab that from this package.json file here where you can see a dev dependency for the AWS SDK. So once that's done, I'm able to try running my local Lambda function code using my test harness. And you can see here I've got an error. I can look at this error here and there's something wrong with the S3 bucket. It's expecting an AWS region. Okay, no bother, I'll just add that to the environment file. So I know that I deployed my resources to US East 2. I'll just add that in now. Okay, I've added that environment variable to my environment file and I'm ready to try running my function code again locally. So I'm going to do node testharness.js and there you can see that it's executed successfully. I've got the correct message, I've got an e-tag code, and I can verify that by using the AWS CLI for S3 to check that there is a file that's been written to S3. So the command for that is ls, AWS S3 ls, and then the bucket name, and this should show me that there's a new file in there. a new txt file, and there it is. So that's how I'm able to test my Lambda function code locally, even against managed services that have been deployed to an AWS developer account. So, just to summarize everything we've been talking about in this session, serverless technologies is for developers who want to focus on business logic and who don't want to pay when their app is not running. They want their application to scale on its own without having to manage the infrastructure that their application relies upon. Serverless is very much about using a managed service approach that helps you decouple business logic from other application components. For those unique parts of your application where managed services can't be used, write your business logic and deploy them to AWS Lambda functions. Use Amazon API Gateway to access these Lambda functions, creating a front door to your application. And build your serverless applications with a template such as AWS SAM to help you describe, deploy, and manage your AWS application resources. I've mentioned this a few times already. There's a brand new Getting Started blog series on the AWS Compute blog, and it's very much in line with what we've been talking about today. It's all about getting started with serverless for developers, and it's a great place to kick on and learn more about serverless technologies. Another excellent resource is serverlessland.com. Now, this is a kind of content aggregation site created by the AWS Developer Advocate team, and it contains blog posts, videos, and learning paths, and upcoming events. It's everything to do with serverless at every level, from people who are brand new on their serverless journey, right up to those that are already running serverless applications at scale in production. Thank you so much for listening to me today. I hope this session's been useful for you. If there's any questions which are still unanswered for you, then please do reach out to me on Twitter. My name is Benjamin_L_S. And please do reach out and let me know what you're going to be trying next with serverless technologies. Thanks again.